Today, we'll be looking at logarithm. Now, logarithm goes hand in hand with indices. In case you really don't understand the topic indices, take out time, check our description, and click on the video to direct you to the lectures that have been taken on indices. Now, once again, indices and logarithm go hand in hand. So I will enjoy you to please take out time and go through the video. If this is your first time of stumbling on our channel, and if you like what we are doing, give us a thumbs up and also kindly subscribe to our channel. Also, click on the notification bell so that you'll be the first to get an alert when a new video is released. From the previous class on indices, we want to describe indices in this simple mathematical notation. I'll be using y equals to a raised to the power of x, where for the number y, a is the base while x is the index of the number. Now, when we talk about index, we say it's actually the power or the exponent. So you call it index, you can call it exponent, you can as well call it the power to which a number is raised. Let's look at a simple example. If we have a number 8, we can say 8 is the same as 2 times 2 times 2, which indicates that 8 is actually equals to 2 raised to the power of 3. Your 3, which is the index, indicates the number of times 2 multiplies itself. And we looked at different laws of indices in the previous class. So today, what is logarithm? I've just said that logarithm and indices go hand in hand. So we describe logarithm as the index to which a base is raised to actually be equal to a number. So if I have y equals to a raised to the power of x, it simply means that x is the logarithm of y to the base of a. Or if we look at the example I have here, which is 8 equals to 2 raised to the power of 3, it simply means that, and it can be written like this. I'm going to use this notation. I'm also going to use this for clarity. Now, we've understood very well that I said that logarithm is the index to which a base is raised to be equal to a certain number or an ordinary number. So if 8 is our number, 3 is the index, 2 is the base, we can write our logarithm as, say, log of 8 to base 2 is equals to 3. The same way we can express any ordinary number as log of y to base a is equals to x. So we can see that the logarithm of an ordinary number is actually the power to which the base is raised. So let's evaluate these logarithms up here. The first one says evaluate log of 32 to the base of 0.5. Now the best And the first thing to do is to equate it to an imaginary number. And most times we represent this number by one of the letters of the alphabet. So I would prefer to use the letter X. Sometimes I might use B, I might use C. There is no specific letters to be used. So I'm going to use the letter X. So I can say that log 32 to the base of 0.5 is equals to X. So to evaluate this, I'll bring it back into the index notation. Remember that your logarithm is the index to which your base is raised. So what's our base here? Our base is 0.5. So it's 0.5 raised to the power of X equals to 32. Now, I can actually convert this into a fraction so that I can work with it easily. So 0.5 is the same thing as 1 raised over 2 raised to the power of X, which is equals to 32. Remember, in our laws of indices, we say that when we have a fraction like this, we can rewrite it as 2 raised to the power of minus 1. Remember, multiplied by the X. So we have 32 is still equals to 32. But this further can be this. And 32, if you find the factors of 32, remember when we talk about factors, we are talking about the multiples to give these numbers. So the multiples of 32 is, we use the factor 2 in this 1, remainder 1, 12 is 6, 2 in 16, 8, 2 in 8, 4, 2 in 4 is 2, 2 in 2 is 1. So we have 32 is equals to 2 raised to the power of 5. The number of times 2 multiplies itself. So we go and write it as this. Now, to further solve this, we'll equate the base. And our base is 2. So it means that if we equate this, it brings our equation to minus x equals to 5. So it means that our x will be equals to what? Minus 5. So we have been able to solve for this. And now we know that the logarithm of 32 to the base of 0.5 is equals to minus 5. Let's look at the second question. We have log of 0.04 to the base of 5. Now let me change the letter I'm going to use. I'm going to be using different letters to make us know that we can use any letter. All we want to get is the answer to the question. So I'm going to use the letter A. And so with this, we can go on. Once again, rewrite in index notation. And when we do that, it simply means that our 5 raised to the power of A is equals to 0.04. Remember, when you have decimal numbers like this, it is best we convert it to fractions. So if you're going to convert that to fraction, we'll have, this is 4 all over 100, which is the same thing as 1 all over 25. So we have 5 raised to the power of A. Remember, we're going to write this in a simple index form, which is 5 raised to the power of, or minus 2. How did we get here? Some people would ask me, how did we move from 1 all over 25 to 5 raised to the power of minus 2? Our 1 all over 25 is the same thing as 1 into 5 times 5. So it's the same thing as 1 raised to the power of 5. Sorry, it's the same thing as 1 all over 5 raised to the power of 2. Once again, we use our index notation of inverse fraction. So we have it as 5 raised to the power of minus 2. And that is how we arrived at this. So let's go on. Once again, we equate the base. And when we equate the base, it gives the index equals to A equals to minus 2. So that is our answer. So we have A equals to minus 2 as the logarithm of 0.04 to the base of 5. Have solved the first 2 questions. Can we try the next 3 questions on our own? I'm going to wait for us. We can actually pause the video and try to make an attempt on this remaining 3 questions. I want to believe that we have tried these questions. Let's see if the answers you got is the same with what I got. So let's work it out. Our question 3 is actually log of 27 to base 3. Once again, we are going to equate it to any letter of your choice. I'm still going to use the letter A. So we are going to bring it to index notation again. 3 raised to the power of A is equals to 27. 3 raised to the power of A is the same thing as 3 times 3 times 3, which is equals to 3 raised to the power A equals to 3 raised to the power 3, making our A equals to 3 because we equate the base. So our index can be equal to one another. So our A is equals to 3. Did you get that? If you did, thumbs up to you. Let's see question 4. The 4th question. I'm sure it's getting easier as we try. It says log 32 to the base of 2. Once again, I can decide to use the letter Y, any letter of your choice. So I'm going to write it again in index notation. 2 raised to the power of Y equals to 32. Remember, 2y equals to 2 raised to the power of 5, because 32 is actually 2 multiplied by itself in 5 places. So we know that our equating the base, once again, our y will become y equals to 5. If you've done this question and you got the answer again, thumbs up to you. For question 5 now, let's go ahead and find the logarithm of question 5, logarithm of 125 raised to the power of half to base 5. I'll use the letter y. So I have 5 raised to the power of y is equals to 125 raised to the power of half. Remember that we are looking for the logarithm of a number, 125. So it's actually the index to the base. So we know that our base is y. We must try to equate this number to the base. So we must bring this 125 to the base of 5. Very well. If you use our, oh my God, my marker is working. Now if we use base of 5, we know that 125 is 5 multiplied in 3 places. So which is 5 raised to the power 3. Remember, 3 sorry, 5 raised to the power of 3 times 1 over 2 is the same thing as y. So we can equate our bases and then equate the index. So it's giving us 3 all over 2, which means that our y is equals to 3 all over 2. So the logarithm of 125 raised to the power of half to base 5 is equals to 3 all over 2. Or you can further write it in decimal point as 1 raised to the power of, oh, did I say 1 raised? 1.5. Thank you.